Okay, we are done with the slope of the tangent line. So we will relate that to the definition of the derivative. So what is the relationship between the derivative and the slope of a tangent line? Here's the formal definition of the derivative. We will let our f be a function defined on an open interval. I is a subset of R or a real number, and let x sub 0 as an element of that interval. The derivative of the function at x sub 0 is defined to be the f prime of x sub 0 is equal to the limit of f of x minus f of x sub 0 over x minus x sub 0 as x approaches x sub 0, which we know this is also equal to the slope of the tangent line. So it means that the derivative of the function at x sub 0 is the slope of a tangent line at x sub 0 and x sub 0 if this exists. So again, the derivative is the slope of a tangent line. Okay, as we go on further, let's look upon the different notations of a derivative. So if y is equal to the function, the derivative of f is commonly denoted by the f prime of x, in which I have shown earlier. That means that we are getting the derivative of a function. The dx of f of x, another notation, which means to get the derivative of a function. ddx of f of x, um, the dx of y, and dy dx individually. This means that we will be getting a derivative of a function. So either of these notations, it means we will get the derivative. Um, we will use the slope of a tangent line to get the derivative of a function. So another reminder here that the limit definition of derivative is inherently indeterminate. It means that the usual techniques for evaluating limits which are indeterminate type 0 over 0 are applied. Example, the factoring or rationalization or any algebraic or mathematical manipulation just to get the actual value of the derivative or the limit of the function. Let's solve. Compute the f prime of 1 for each of the following functions. To f prime of 1, we are getting the derivative of the function at x is equal to 1. Okay, number 1, f of x is equal to 3x minus 1. Number 2, f of x is equal to 2x squared plus 4. Number 3, f of x is equal to 2x over x plus 1. And number 4, f of x is equal to square root of x plus 8. Okay, let's solve number 1. Okay, compute the f prime of 1 of f of x is equal to 3x minus 1. Now using this formula of the slope of a tangent line, so we will get the x sub 0, which is in this case the x sub 1. I mean, yeah, x sub 0 is equal to 1 rather. So x sub 0 is equal to 1, and the f of x sub 0 is unknown, so we will get that 1. So f of 1 is equal to 3 times 1 minus 1, that's equal to 2. Okay, so since we have the x sub 0, the f of x sub 0, in the function, we can get the derivative of the function using um, the formula to solve the slope of a tangent line. So limit of f of x, which is 3x minus 1, minus the f of x of 0, in which we solved earlier, 2. So that's minus 2 over x minus the x of 0 is 1 as x approaches the x of 0, or 1 again. So 3x, and then negative 1 minus 2, that's negative 3. So 3x minus 3 over x minus 1. This is indeterminate form, 0 over 0. So, okay, so let's factor the numerator. 3x minus 3, the factor of that is 3. times x minus 1. So x minus 1 is common in the numerator and the denominator. We can cancel that. So it remains the 3. So the limit of a constant is the constant itself. So the answer is 3. So the f prime of 1, or the derivative of a function at x is equal to 1, is equal to 3. So the function is 3x minus 1. Okay, so for number 2, we'll get the f prime of 1 with the function 2x squared plus 4. So again, the x of 0 here is equal to 1. Now, we don't have the f of x of 0 or the y of 0. So let's get that first. So f of x of 0, that's f of 1 is equal to 2x squared, or 2 times 1 squared plus 4. Okay, so 1 squared times 2, that's 2 plus 4 is equal to 6. This is our f of x of 0. So the f of x of 0 is the the f prime of x of 0 is the f prime of 1. So the formula, limit of f of x, which is 2x squared plus 4, here, minus the f of x of 0, which is 6, over x minus the x of 0 is 1. As x approaches, the x of 0 is 1 again. Okay, so 2x squared plus 4 minus 6, that's 2x squared. 4 minus 6 is negative 2 over x minus 1. And again, this is 0 over 0 if we direct substitute the value of x with 1. So let's factor the numerator first to get the real or actual value of the limit. So 2x squared minus 2, the factor is 2 times x squared minus 1. And then we can factor actually this x squared minus 1, which is x minus 1 and x plus 1. So the factor is 2 times x minus 1 and x plus 1 over x minus 1. And then the common here is x minus 1. So that's 2 times the quantity of x plus 1. Let's substitute the value of x with 1. So 1 plus 1 is 2, and 2 times 2 is 4. So the f prime of 1 is equal to 4, and this is the derivative of the function at x is equal to 1.